Here it's just asking to do some composition. So f compose g of x, we know by definition is f of g of x. In our particular problem, g of x is 1 over x. And so if I do f of 1 over x, I'm going to take that 1 over x and replace the x's with 1 over x. And 1 over x squared is just 1 over x times 1 over x, which is 1 over x squared. Okay there?
Yeah.
Okay. And then g compose f of x is just g of f of x. In this problem, the f of x is x squared minus 3. So when I plug that into 1 over x, I have just 1 over x minus 3. So the problem, or the answer, is just slightly different, right? One of them, the minus 3 is in the denominator, and the other one, it's not. Cool? Okay. Anybody else on questions before we finish up section 7 here? Okie doke. Well, let's do it then. So in section 7, we were last talking about finding inverses. And we saw how to find the inverse for a relation. What if we want to find the inverse for like a set of ordered pairs? Where did that example? Oh, there we go. So let's say we have this function that's defined for these, or defined by these 4 points. If I want the inverse, we had talked last time about the inverse is basically just undoing whatever the function did. So our function sends -2 to 4. So our inverse needs to send 4 back to -2. It sends -1 to 6, so we have to send 6 back to -1. Sends 3 to 8, so I have to send 8 back to 3. And it sends 5 to 8, so I have to send 8 back to 5. There's my inverse. Yay! Worth noting that my original function was not 1 to 1, because I have a repeated y coordinate. And as a result, I know then my inverse will be not a function, because I have now a repeated x coordinate. That was one of the observations we made last time. Everybody okay with that? What if our function looks like a graph? How would I do that? Let's say we have this graph. what I would do is I'd identify some points on my graph. So like maybe I use my grid, I estimate this one to be 0, -3. Maybe this one is -2, 0. And maybe this one is like 3, 6 or something. Well, just like in the previous example, what I'm going to do is I'm going to transpose these x and y coordinates and plot the new locations. So like 0, -3 becomes -3, 0. -2, 0 becomes 0, -2. And then 3, 6 becomes like 6, 3. And then since 0, -3 was the vertex for my function, -3, 0 should be the vertex for my inverse. So if I draw my inverse, it should look then like this. And that's probably the easiest way to handle one of these graphical ones, is just to identify a couple of points from our function, transpose the points, and draw your new graph. As a good check or an alternative way of approaching this kind of a problem, there is a relationship between a function and its inverse graphically, and that is that the function should be, or the inverse is a reflection of the function across the line y = x. So like if I take this part of my function, when I reflect it across y = x, it gives me like that part of the inverse. If I take this part of my function and I reflect it across the line y = x, I get this part of the inverse. And then if I take this part of my function and reflect it across that line, I get this part of my inverse. Now I think visually it's difficult to kind of see that and do that as your primary method. That's why I showed you like using the points and transposing those as our initial method. But this is a good check to make sure that like after you've plotted your points and drawn your graph, you didn't make an oopsie. Is to just be like, okay, if I take this part and I flip it over, do I get that part? Yeah, that looks close. And if I take this part and I flip it over, do I get that part? Yeah, that looks close. Just to give you a good idea after you've drawn your graph, like it's an easy check because it's just visual, right? You just have to kind of look at it and go, oh, that looks right, or oh, boy, that I did something's not right here. Does that feel okay, guys? Okay. Again, observe that f of x was not 1-to-1 because it would fail a horizontal line test. There would be two y's assigned to, or the same y assigned to two different x's. And as a result here, obviously f inverse isn't a function, right? That was one of our observations we made yesterday. And then the last way that we talked about, we need to talk about finding inverses, is if we represent our function with an equation. So let's say we have an equation like f of x equals 3x minus 7. So here we can't just worry about transposing x and y coordinates because we're not given any coordinates. Ben? Sure. So this is the process when you're given an equation to deal with, is you first start by getting rid of the function notation. So we just replace the f of x with a y equals. Then we're going to use algebra to get x by itself. So in this case, I'll add 7 to both sides. And then divide both sides by 3. And that gets me the x all by itself. Everybody so far so good? After you've isolated the x, we're going to swap the variable names. So everywhere there's a y, I'm going to write an x. And everywhere there's an x, I'm going to write a y. This is like when we transpose the coordinates. It's basically doing the same thing. And then my last step is to put it back into function notation. So instead of y, I'm going to write f inverse of x. And there's that. Are we okay there? Relatively easy process. That process stays the same regardless of what the equation looks like. The only thing that might change is the algebra steps we use to solve or to get the x by itself will change depending on kind of what we have there. Now keep in mind to check to see if these two things are inverses. We can do that. Remember last time we talked about the definition of an inverse? So to do that, we need to check two things. We need to do the composition of f and f inverse, and then the composition of f inverse and f. Both of these compositions should give us the same thing, and that thing should be x. So let's just do that check now to kind of show you what that looks like. I think there's a couple of problems in the homework set that ask you to do this. So our definition of composition says that f of f inverse, or f compose f inverse, is f of f inverse. We found above that f inverse was x plus 7 over 3. So what we're going to do is we're going to plug x plus 7 over 3 then into f. So I'm going to have a 3, and then instead of x, I'm going to write x plus 7 over 3, and then I have my minus 7. So now all I need to do is simplify. I have a times 3 and a divides by 3, so those will cancel out. I have a plus 7 and a minus 7. Those will cancel out. And I'm left with x. I'm not finished yet. I still have to do the other direction, though. So again, according to our definition, f inverse compose f is f inverse of f. In this situation, f was 3x minus 7. So when I plug that into f inverse, I'm going to replace the x's with 3x minus 7. So the minus 7 and plus 7 cancel. Then I have 3x over 3, so the 3's cancel. And I'm left with just x, which is what I was supposed to get if these two things are inverse. Everybody okay here? Okie dokie. Let's look at another example like this. What letter are we on now? I think D. So this one is a little bit more challenging algebraically because I have x in 2 locations instead of just 1. Everybody see that? So still going to start the same way. I'm going to replace the function notation with a y equals. And then if it's me, the first thing I'd want to do in this situation is to get rid of the fraction. So the easiest way to do that here is to just like cross multiply. Again, cross multiplication is a solving technique, not a way we multiply fractions. We multiply fractions straight across, but if there's an equal sign in between them, we can get rid of the fractions by doing this cross multiplication thing. Everybody's okay with what I did? So this is nice because there's no more fraction because, well, who wants to deal with that? What I'm going to do next is I'm going to just distribute this y through because I'm eventually going to want to get the x's all on one side and the non-x's on another. But before I can get to that 5x, I have to distribute that y out of there, or through there, I should say. And then I'm going to subtract the 5xy from both sides and subtract the 5 from both sides so that I get the x's all on one side and the non-x's on the other. If I look at the left-hand side now, I notice that both terms contain a factor of x. Everybody see that? So I can factor a greatest common factor of x out of that. Which is important because that's what allows me to go from x's in 2 places to an x in 1 place. Landon? I factored, right? Like I noticed there was 1 x in both locations. So I can just take a greatest common factor out.
Oh.
Just like if I had like 2x plus 5 minus x squared, I can take an x out. Hi, Maria. Thanks. And then we'll just divide both sides by 2 minus 5y. And now I got that x by itself. From here, we'll swap the x and y coordinate so that everywhere where there's an x, I'm going to write y. And wherever there was a y, I'm going to write an x. And then we'll put this back into function notation. This problem, we had a g of x, so this will be g inverse. And this is probably not the way that I would leave my final answer, because I noticed that if I just multiply the top and bottom by a -1, I'll go from having a problem where I have 3 negative signs in it to a problem with 1 negative sign in it. Although the previous one wasn't wrong, if you're doing a multiple choice test, they probably wouldn't write the answer that way. They'd probably write it the way that I boxed it. that's a little bit simpler. Just for the record, I wouldn't mark the previous one wrong, though, on a test or whatever. That's just a matter of style. Yes?
When is the test?
Soon. We'll talk about it here in a few minutes. Still doing okay, everybody? Okay. Let's do another then. So we'll start by writing this as y equals. And then to get the x by itself, what's the first thing I should do here? What do you guys think? Trying to get the x by itself, right? What? Well, I wouldn't do square root yet, but eventually I will. I wouldn't do that yet, but eventually I will. Victoria? Add the 4. Right, remember when we're solving like this, which is basically what we're doing, we go the reverse order of operations. So we're going to undo addition and subtraction, then multiplication and division, then exponents or operations. So we added 4 to both sides. Now we'll divide by the 3. And then we'll square root both sides. Important to remember, though, when I square root both sides of an equation, what do I have to do? When I square root both sides of an what? Yes. That's something I would assume that probably 2/3 or more of us would forget without being reminded. This is me reminding you right now that when we square root both sides of an equation, we need to make sure we include a plus or minus. So don't forget that. We now have, or we swap the variable names, so x becomes y and y becomes x. And then we can rewrite this as a function, or in function notation, I should say. Worth noting, is h inverse of x a function? Should be able to tell by just looking at it. No! Why not? What's going on with this one that would have been my dead giveaway? The plus or minus, very good. So what does that probably tell us about h of x? That it wasn't 1-to-1. And in fact, it would have been easy to say that, because what kind of a function is h of x? Starts with a Q. Quadratic. How did I know it was quadratic? The x squared. What's the shape of a quadratic function? A parabola. Does that pass a horizontal line test? No. So again, this is not 1-to-1. And not surprisingly, our inverse then is not a function. Just as to point that out to you guys. Right, that was one of the, we spent some time last time kind of talking about that and developing that idea. I just wanted to, it's been a couple of days, so I wanted to hammer that a little bit more with my little tiny math hammer. Ding, ding. No? Okay. What letter is this? Is it F, I think? Whatever, my alphabet will skip some letters or maybe have some letters come twice. Who cares? right? Not that big of a deal. Spelling's hard, guys. The math is the easy part. The alphabet, don't get me started on that. I'm making jokes, but not really. As an elementary student, those were my worst subjects, like penmanship, spelling. It's like, ugh. How come there's no rule for this? Again, we'll start by replacing the function notation with the y equals. And we want to get the x by itself. What's the first thing we have to do? We got to get rid of that radical, right? How do I get rid of that square root? What's going to cancel that out, Landon? Good, yeah, we'll square both sides. Everybody agree? Okay, so that'll give me, well, maybe we'll write it. Uh-oh. What happened to my pen? Hey, you. So when we got the new computers, the teachers here, they gave us like these new pens, and they stink. Like the old pen was so much better. Number one, who wants to write with a pencil that's like 3 inches long? Like it's just an irritating length. And then two, like it just seems to be really inconsistent and just stop working for no good reason every so often. Anyways, that's just me griping. So I squared both sides, now what? Subtract 5 and then? Divide by 12, right? I'm going to do that all in one step. Is everybody okay with me doing that? Just squeezing both those things into one step. It's just a little bit less writing for me, and boy, am I lazy. Okay, my last step would be to switch the x and y variables and then put it back into function notation. I'm going to do both of those two things in one step. Hope that's okay with everybody. All good? Okay. If G, do another one. Get into some of the tricky little buggers. Yeah, I sure hope so. Ah, ha, ha. So again, start by getting rid of the function notation. Just replacing with a y equals. What kind of an equation do we have here? Does anybody recognize this from last year? At least we should recognize it. This was an exponential equation. I can recognize that because the x is in the exponent. Does that ring a bell? Okay. Again, we want to get the x by itself. The first step I do is divide by -1/2, which is the same thing as multiplying by its reciprocal, which is the way I would think about it, since it's involving a fraction, but it's the same thing. So I'll multiply both sides by -2. That's the same thing as dividing by -1/2. Either way of thinking about it is fine. I like multiplication for reciprocals when fractions are involved, but, you know, to each his own. Everybody okay here? So far, so good? Now we got to get rid of that 3, right? That 3 is an exponent base. Do you guys remember what gets rid of an exponent base? Begins with an L. A logarithm. So the question becomes, which logarithm should we use here? There is a best choice. I should choose log base 3. Why 3? it matches the exponent base, right? I want the log base to match the exponent base. It's okay if you're like, yo, I do not remember much of this. That's okay. We're going to redo logs again in second semester. But this provided me just like a nice opportunity to review some of these things that we did do last year that we should still kind of remember. So the big takeaway here is log base 3 cancels exponent base 3. Hopefully this is starting to at least symbolically look a little familiar, even if you're like the vocab is like did not stick at all. The symbols now are like, oh yeah, I kind of remember doing that. And then my last step here would be to, well, at least last thing I need to do to get the x by itself. We gotta divide by 4, right? Now, this is another case where I would probably write it this way. Just because if I was gonna say log base 3 of -2 over 4 is not the same as log base 3 of -2y all over 4. Those aren't the same thing. And rather than me having to sit there and think about which one do I mean, I'm just going to stick the 1/4 out front, and then I don't have to worry about like, am I dividing inside the parenthesis or across the whole thing? Can I divide inside? And you don't have to think about any of those kinds of questions. We'll just stick it out front. It's fine. Is that okay with everybody? So then I will replace my function notation and trade out the x's and y's. I don't know, I think I'm on G or something. This will be the last example here. So I have k of x equals 5/3 natural log of 7x minus 1. Remember the letters ln stand for the natural log. So replace the function notation with a y equals. First thing I would want to do is Landon? Logs don't distribute, so if I have like log of a plus b, that's not equal to log of a plus log of b. So that's not something we can do. I would multiply both sides by 3/5 to start. Or think about it as dividing by 5/3 is fine also. But I want to get that coefficient out of there. Is that okay? Hopefully you're like, oh, sure, duh. Now we got to get rid of that logarithm, right? So does anybody remember what cancels a logarithm? What was that? No? So remember before we had that we used a logarithm to cancel an exponent base in the previous problem. So we're going to use an exponent base to cancel the logarithm. Everybody good with that plan? The question becomes, which number should my exponent base, or which number should I use as my exponent base? There's a best answer here that makes your life considerably easier. The base of my exponential should match the base of my logarithm. Does anybody remember what the base is for the natural log? It's what? It's not 10. 10 was for the common log. That was the other one that we didn't write the base for directly. The base for the natural log was e. Remember, e was that irrational number, kind of like pi, that we developed. So I'm going to write my big E. And again, I know it looks silly with the E being that big, but I really want to make it clear in my notes that that E is not being multiplied, rather that it's the base of an exponential. And so the exponent base E cancels log base E. That's the natural log. Well, somebody's volume is way up. It's okay to there. And then I'm left to add 1 and divide by 7. Right? Add 1 to both sides, divide both sides by 7. And I'm going to do that both on the same step, if everybody seems okay with that. I can then put my function notation back and swap the x's and y's. Oops. And there we go. Feel okay here? All right. That's going to end section 7 for us.